The scientists are looking for exoplanets, but despite their efforts so far, it's very extraordinary that the universe is so big, but our planet is the only one. Conditions right for life, and that it looks specially created and very well protected.
Prior to 1995, there had been many attempts for the detection of planets around other stars, and these would be extrasolar planets. Every discovery to be subject to or just incorrect. But in 1995, two teams, a planet around Pegasi. This was a real observation of a planet around. At that point, there was a very great sense of euphoria in the scientific community because for the first time we began to have techniques that are sensitive to other stars. In 1995, the expectation was that there are planets up in other stars, planets like very easily observable. If you look at the statements made, for example, to national academies or American scientists talk about billions of Earths just within. But in fact, 1995, as our even more improved, yes, what we have seen is thousands of planets. We have seen thousands of planets around other stars. But then when you ask the conditions, that's with what you find, but like planets, there essentially are not. Because the requirements for an Earth-like planet are many. The to be situated in the habitable zone is essentially a distance where the temperature of the mean temperature of the planet water can at least planet. So if you're too close, you end up having is that there is excess and the heat evaporates the water, a greenhouse effect. This causes a effect that geologists call the moist greenhouse, leads to a runaway greenhouse, and so that all the water evaporates. When it gets to the edge of the atmosphere, where a particle sends a particle on a hydrogen off the upper planet, and it becomes desiccated. It doesn't just stay moist, it actually gets desiccated. On the other hand, if the too far from the sun, star, then the moisture snow down on the surface of the planet, where the albedo, which is the reflectivity of the planet, goes up. As it does that, the planet temperature drops, which causes more snowing, and you end up in a situation of snowball Earth. So you have a runaway greenhouse on one end and a snowball on the other end, and only in the middle, perfect state. Now, calculations have been done, say from before I get into a runaway. Some of these calculations put it at 1%. 1% closer into a runaway. So we are very, very perfectly situated from the distance. Then the point is that not all stars are the same. We have a very stable, energetic star, massive energy. If our the more common stars, like which would be a cooler star, the habitable zone is closer to the moon. But when I'm that, I'm very close to it, which is very stable. M stars have a lot of strong energy output changes. Damage planet. The other thing that happens is that the night, which is as you get closer, there's a gravitational effect called friction locking. It locks the planet. One side of the planet is all light that's seen. It totally burns up. The other side just is super chilled. Two number of together for